Hi, I'm Aaron Kaplan of Luna Technologies, and today I would like to share with you a brief demonstration of distributed strain sensing using Luna's Optical Backscatter Reflectometer, or the OBR. The OBR has the unique capability of measuring strain continuously along the length of standard optical fiber up to 70 meters in length. What the OBR measures is the strain as a function of distance along the fiber, a measurement we refer to as the strain profile. The user, today being me, has the ability to define a region of interest along the fiber over which to measure strain and the sensor spacing and gauge length within that region. The gauge length is synonymous to the gauge length of traditional foil-type strain gauges. So here is our test sample. It is a hollow plastic cylinder mounted only at one end, and our optical fiber is bonded around the outside of it in a helical pattern. The fiber is bonded using standard strain gauge epoxy. What we expect to happen is that as I displace the free end of the cylinder down, the top side will elongate and the bottom will compress. We are measuring the strain experienced by the optical fiber. Because it is wrapped in a helix, we expect the strain profile to be a sinusoid. As the fiber crosses the top of the cylinder, it will experience tension, and as it crosses the bottom, compression. We also expect the sinusoid to decrease in amplitude. This is because the cylinder experiences the most strain closest to the mount and the least at its tip. What do we expect to see if the cylinder is twisted? If it is twisted in the same direction as the helix, the fiber should uniformly elongate and cause a positive DC strain profile. So let's hook it up and see what happens. First, I am displacing the tip of the cylinder downward, and we see the sinusoidal strain profile decreasing in amplitude as expected. As I displace the beam upward, we see the strain profile invert. Now I am moving the tip of the cylinder in a circle, and we see the phase of the sinusoid vary. Notice in the top left we are observing 26 centimeters of fiber with a 4 millimeter gauge length and a 4 millimeter sensor spacing. Now when I let go of the beam, the strain profile will return to 0. Now I am twisting the beam against and then with the helix, which is difficult to do without displacing it as well. And finally, I am twisting against the helix while displacing it, causing a negative DC offset to the sinusoidal strain profile.